Imagine stepping into a booth in your living room and instantly reappearing on the other side of the planet. No cars, no planes, no waiting, just teleportation, like something out of Star Trek. But here's the burning question: could we ever build a real-life teleportation machine? Or is it just science fiction? Hi, I'm Wabi, and today we're diving into one of the wildest ideas in science: real teleportation. We'll explore the physics, the technology, the experiments already happening, and the mind-bending challenges that stand in the way. Stick with me to the end, because you're about to see that teleportation might not be as impossible as it sounds, but it's also not what Hollywood promised. If you love exploring the edge of science and imagination, hit subscribe right now, and let's begin this journey.
Zombie apocalypse.
1. What do we mean by teleportation? When people think of teleportation, they imagine disappearing in one place and reappearing instantly somewhere else. But scientifically, teleportation means something deeper. It's not about physically moving atoms from A to B. Instead, it's about transferring information, the complete blueprint of a particle, atom, or even a human, and reconstructing it elsewhere. Think of a fax machine or email. You don't send the original paper, you send the information to recreate it somewhere else. So the real question becomes, can we scan every detail of something down to the quantum level and rebuild it perfectly somewhere else? That's what teleportation would mean in real life. 2. The physics behind teleportation. Teleportation isn't just fantasy. The science behind it comes from the strange world of quantum mechanics. In particular, quantum entanglement. This is a phenomenon where two particles become so deeply connected that whatever happens to one instantly affects the other, no matter the distance. In 1993, scientists proposed the idea of quantum teleportation, using entanglement to transfer the quantum state of one particle to another, without moving the particle itself. And here's the shocker: this isn't just theory anymore. Experiments have already teleported information between photons, electrons, and even atoms. The farthest distance achieved so far is over 500 kilometers using satellites in space. That means teleportation is real, at least on the quantum scale. If that just blew your mind, smash that like button so I know you're still with me. 3. The first problem: scanning humans. Okay, now let's get serious. If we wanted to teleport a human being, the first step would be to scan every single atom in your body. Sounds simple. Think again. The human body contains about 37 trillion cells. And each cell contains billions of molecules. That's around 10 octillion atoms in total. Now imagine recording the state of every atom, its position, velocity, energy, and even its quantum state. The amount of data would be astronomically huge. Some scientists estimate it would take more digital storage than exists on Earth today, multiplied by trillions, just to describe you. And here's the kicker: according to the uncertainty principle, it may not even be possible to measure everything perfectly without destroying the system. So teleportation of a human isn't just hard, it's close to impossible with today's physics. 4. The data transfer nightmare. Even if we somehow scanned you atom by atom, we'd still have to transmit that information. Let's say we could somehow compress the data into a super streamlined format. Even then, sending the blueprint of a human might take millions of years with today's internet speeds. So not only do we need revolutionary physics, we'd also need technology far beyond what we currently have for data transfer and storage. Teleporting a human isn't just a physics problem. It's also a massive computer science problem. If you're loving this breakdown of teleportation's challenges, don't forget to subscribe. I've got more mind-bending space and science topics coming every day. The reconstruction problem. Now let's say you've been scanned. Your data has been transmitted across the world. What next? You'd need a machine capable of rebuilding you atom by atom in a location. That means assembling every molecule, every chemical bond, exactly as they were perfectly, without a single error. Because here is the scary part: even the tiniest mistake in reconstruction could mean the difference between life and death. This isn't like building a Lego set. It's like trying to reassemble a storm cloud in motion. Right now, we don't even have the technology to build one protein molecule from scratch, let alone a living human body. So this part of teleportation is a massive roadblock. 6. The identity question. Let's imagine, for a moment, that the technology works. You're scanned in one place, your data is sent, and a perfect copy of you is rebuilt somewhere else. Here's the mind bender: is that really you? What happens to the original? Do we destroy the first version to avoid having duplicates? If so, does that mean teleportation is basically killing the original and creating a clone with the same memories? This isn't just science fiction. It's a genuine philosophical problem about identity, consciousness, and whether you are more than just the arrangement of atoms in your brain. Teleportation forces us to question the very meaning of self. 7. Teleportation in science fiction versus science. In movies and shows like Star Trek or The Fly, teleportation looks easy. Step into a chamber, push a button, and boom, you're somewhere else. But real science is far stranger. Instead of moving matter itself, we'd be moving information. Instead of instant travel, it could take enormous amounts of time. Science fiction makes it look sleek and simple, but the reality would be messy, slow, and full of ethical dilemmas. 8. Where are we now? So, where are we today? We've successfully teleported photons, electrons, and even atoms using quantum entanglement. We've done it across laboratory distances and even between satellites in orbit. That's groundbreaking, but it's a long way from teleporting living beings. Right now, teleportation is a tool for quantum computing and secure communication, not for travel. Still, every step forward takes us closer to a world that once seemed like pure fiction. 9. Could it ever be possible? Could we ever build a real teleportation machine? Some scientists believe it's theoretically possible, given unlimited technology and computing power. Others say the fundamental laws of physics, like the uncertainty principle, may forever prevent it. But here's the truth: just a century ago, people thought flying was impossible. They thought landing on the moon was a fantasy. They thought splitting the atom was science fiction. So maybe, one day, teleportation won't just be a dream. It will be a reality. So, can we make a real-life teleportation machine? The short answer: not yet, and maybe not for a very long time. The challenges of scanning, transmitting, and reconstructing matter are enormous. But on the quantum level, teleportation is already real. And who knows? 100 years from now, people might look back at our doubts the way we look back at people who thought heavier-than-air flight was impossible. I'm Wabi, and if this video sparked your imagination, hit that like button, subscribe for more deep dives into the mysteries of science, and share this video with a friend who loves to dream big. And remember, the future is always stranger than we imagine. Keep asking questions, and keep looking beyond the horizon.